Yeah. Trigonometry. Trigonometry. Three. Gono. Actually, mainly it is angle. And metry is a measurement. Okay. So mainly trigonometry. In the trigonometry, will deal with three angles. Mostly say like this, right? 1, 2, 3. And though the history of trigonometry is writing in different book in different form, so actually this trigonometry is invented in India, basically in India. The application of trigonometry is huge. So step by step we will see the application of trigonometry. In order to understand trigonometry, what we have to know, we have to understand clearly about the triangle, especially right angle triangle. Okay, right angle triangle. What's the definition of right angle triangle?
One right angle, sir?
One angle is right angle. This is the definition of right angle triangle. So this is the definition of right angle triangle.
Oh, it's not coming. Whatever Baba writing in the video.
Okay. Right now, I can see this is the right angle triangle. If I can define it A, B, C, and in terms of angle, A, B, C is right angled. That is 90 degree. And since it is a triangle, it has 3 arms, right? And the arms is A, B, B, C, C, right? So we have to understand the definition of these 3 arms. What is the definition of AB?
Definition?
Yeah, what is the definition of AB?
Maniki.
What we called? What's the name of AB?
Oh, perpendicular.
Perpendicular. Okay,
Jadi eta theta, right?
Yes, that's I'm coming a little bit later. So what's the definition of BC? As by your thinking and you understand, adjacent, base, or adjacent. And what's the definition of CA? Hypotenuse. Yeah. As we are telling, this is called this, but this can be changed, right? So it's a right angle, and we have to actually define another angle. With respect to that angle, we have to define the perpendicular, adjacent, hypotenuse. So for examples, if we consider this angle is theta, right? As with respect to this theta, you have to define the perpendicular, adjacent, and hypotenuse. So if this is the theta, the opposite of theta is perpendicular. Adjacent is the connection line
From theta to
on between theta and 90
Right angle.
degree. Right angle is the connection line, right? Theta and 90 degree. And hypotenuse is opposite of right angle 90 degree. This is the definition, right? So if we press theta not here, say theta is here, then this scenario will change. Then perpendicular will be
PC.
opposite of theta is a PC, right? Opposite of theta, I can put it double marking so they can understand based on these. And the adjacent will be
AB.
AB, right? And that hypotenuse will be, it's remaining same because this right angle didn't change. So this is the basic understanding of the right angle triangle. It can be in many different forms. If we think this way, and this is our right angle triangle 90, if we say consider this is the theta, then this is B, and say A, C, right? So what's the consequences? It changes, right? Situation it changes, because still we define this is the hypotenuse, right? This is the hypotenuse, and hypotenuse and opposite of theta, this is the perpendicular, and connecting line theta and 90 degree, this is the base. So this is if you put the angle here, right? So if you put angle here, the situation will change, right? This definition will change. This is the basic understanding of actually right angle triangle, and it's very, very important. And in your book, I have seen that many different way of right angle triangle, and you can practice a lot. So maybe it's like this. So this is 90, right? And this is theta, A, C, B. You can play with the three things: perpendicular, adjacent, hypotenuse. Or if it is angle here, what will be the situation, right? Similarly, maybe right angle is other side, right? Like that. This is 90, and say this is theta, this is double theta, right? If theta is here, what's the situation? And theta is there, what's the situation, right? Many different way you can play around based on the position of your angle. I think we have drawn already this type. Right, this is your 90. C, A, B. If theta here, theta there, right? Many different way you can draw your triangle, and you can play the definition of three important arms of right angle triangle. It's very, very important actually. So after that, what you can do is very basic actually. It's the very basic of trigonometry. How is your computer? Keep on out. Yeah, so that's the things actually in your book. It's a many many different forms. Yeah, so many different forms is there. So though, then when you understand about this adjacent, perpendicular and hypotenuse, this first basic rule or formula of right angle triangle, that is called Pythagoras. How we spell it?
Pythagoras.
Pythagoras theorem, right? That is, if you have a right angle triangle, right, it is 90 degree and say BCA, right, and your if we go back and AB, say the X is your what's called it is perpendicular, right? Perpendicular, and AC is Y is your hypotenuse, and BC, say Z is your adjacent. And the Pythagoras theorem is telling, if you draw a square here, if you draw a square here, right, a square here, and if you draw a square here, draw a square by taking the arm AC, hypotenuse, draw a square by taking the arm perpendicular, right, and draw a square by taking the arm adjacent. So what will be the area of this square? What will be the area of this square? This arm is square, right? Area. This and this are the same. X in if it is Y, right? It is Y. AC is equal to Y. This means that is Y, that is Y, that is Y, that is Y. Right? The area of the square,
Y square,
right? So similarly, area of this square, right? This is
X square.
all of X, and X. It's called X square. And area of this square, right? It's Z, and Z, right? It's a
Z
square. Pythagoras is telling that, so if you sum the area which are drawn on perpendicular on the base, if you do the sum, that will be equal of the area which you have drawn on the hypotenuse. So this is the first actually beautiful theorem about the right angle triangle. It's called Pythagoras theorem. So to understand better of this Pythagoras theorem, definitely you have to understand the definition of perpendicular, hypotenuse, and adjacent. You have to understand properly. That is the first actually basic theorem. And I'm coming back again with that right angle triangle, and it is 90 and CBAC, and right now we can tell that this is the definition. AC is the hypotenuse because it's opposite of right angle, right? And definition of perpendicular and the adjacent depend on the relative theta. So if I put the theta here, we can tell again AB is perpendicular as we defined perpendicular as we defined earlier, and AC is the hypotenuse and BC is the adjacent, right? And when we are dealing with trigonometry, mainly we'll dealing with some trigonometric ratio. Trigonometric ratio those are actually basically 6 of them, but I can say it's 3 of them. Other actually, basically 2 of them, and you can derive from these 2 to others. First one is actually it's writing like this. First letter is small, sine, and other one is called cosine. Cosine. Yes. Is the full form like this, but normally in mathematics it's right like this, and this right like this. And ideally, so this ratio, this sign, so it is cos, it doesn't mean anything if there is no angle after this sign. It has to be some angle. Something is there called angle. That angle is this angle actually, right? So this is the relative angle. And definition of this trigonometric ratio, actually the sine theta is equal to perpendicular
Why you have?
by
I have question.
perpendicular by hypotenuse, right? Perpendicular by hypotenuse, right?
Yeah.
Now the question, the application of this, right? So, for example, you want to know, if you want to know the x value, what's the value of this, and if you know this, say, for example, this 3 is 3 centimeters, right? And if you know this angle, right? If you know the angle, say sine, which is 30 theta is equal to 30 degree or something, then sine theta, it's sine 30 is equal to x divided by 3. So if you know this value and this value, we can find that x is equal to certain centimeters, right? You can calculate it. So it's a particular application is there in many different ways. We'll find out day by day. Cos theta, the definition of cos theta is equal to this adjacent by hypotenuse. Adjacent is BC and hypotenuse is S. Right? In some occasion, maybe you want to know this, or you want to know this, you have given this, right? Actually here, 1, 2, 3 parameters. If 2 are given, you can easily calculate the third one. Okay. Then another trigonometric parameters or ratio we call is tangent. Tangent is like this. And in mathematics, we write here as a tan. And tan, that means has to has theta. And definition of tan actually is sine theta by cos theta. Right? The definition of tan. And if you give here, right, AB by AC divided BC by AC, then ideally you will be getting AB by AC into AC by BC, right? AB by BC. What does it mean?
Perpendicular
Perpendicular.
over adjacent.
Perpendicular by adjacent is the definition of tan theta. So if you know these 3, other 3 It's very easy to understand. So right now, what we know, sine theta, right? We know cos theta, we know tan theta, right? The opposite of sine theta, actually it's another, it's called cosec theta, actually it's called cosecant. Cosecant, like that. Cosec theta, and opposite of cos theta is called secant of sec theta.
Secant.
Secant, yes. And opposite of tan theta is called cot theta, actually cotangent, I think it's called. Right?
Mate, what is the full form of cot?
Cotangent, right? So called cotangent. Cotangent. I am not sure. Okay. So anyway, this is that 6 trigonometric factor. This,
Wait.
this,
What is cotangent
this,
in terms
this,
of sine and cos?
Yeah. What is the tan sine of cos?
1 over
So
sine over
it's
cos.
like this. Think of it. Don't need to be faster.
Yeah.
What about tan?
Sine over cos, sine theta over cos theta.
What does it mean? 1 over.
Cos theta over sine theta is equal to cos theta over sine theta.
So basically, if you know these 3, right, and the relation you can make, it's actually 2, right?
2.
So, and third one.
And
will
later to me
automatically
realize
find.
Korva, it was really just one thing.
Yeah.
Somewhat.
Yeah, somewhat. So that at the trigonometric ratio, we will be playing in different way. Why we need it? Because based on that given parameter of this right angle triangle, right? We will be using this trigonometric ratio, which one will be effective for us.
আমার একটা ছোট কোশ্চেন আছে তুমি জানো কি আমরা ডেনিশ কিবোর্ড ডলার সাইন মানে এজন্য আমি অনেক ট্রাই করছি সার্চ করতে বাট হচ্ছে না তুমি জানো ডলার সাইন
But I think you just ask mom.
Ma, do you know how to make the dollar sign in the Danish keyboard? I tried lots of things but it's not working.
Okay.
Yeah.
And
Here?
and see what if we come here, sine theta, you want to calculate the x, you have given 3, you will not need to know the value of 30 degree, sine 30 degree, right? So in trigonometry there is a table. There is a table in trigonometry. Then actually we can make a trigonometric table, data table. Okay. Trigonometric table.
And
But how do you know what to do it? So all the lower things are L.
and
So by yourself. But maybe it is like this. Yeah, if I can remember properly, this is 1, 2, 3, 4, 5, 6, and say 1, say it's 0 degree, then maybe say it's a 30 degree, say it's a 45 degree, say it's 60 degree, and 90 degree. And our trigonometric ratio, here we call it sine, okay? And Sine 0, actually it's a 0. It's a half. 1 by root 2. Root 3 by 2. It's 1. This value, it can be calculated in many ways, but see, you know this, okay? If you know this, you know all.
Okay.
Right. If you write here the cos, it will start in opposite way. Cos start in opposite way. That means cos 0 is equal to here. Cos 30 is equal to this one. Understand? 45, it will be remaining same. Correct? 60 and 90. Say if you think about 10, right? Then this over this. This over this is equal to 0 over this.
2. Okay.
This over this. This over this. This over this. What is it? 1 by 0.
0?
Can you type in calculator? Let's check calculator now.
Error.
It's your calculator is telling it's a error. It means that, so it's called indeterminate form.
Okay.
So it's writing like this. Something infinite. It's huge. It's not possible to calculate.
You should can't divide 1 into 0. You don't know. You don't know.
No, something by 0.
Anything by 0 indeterminate.
Yes, something by 0 is giving indeterminate forms. Okay? Okay, now if you want to make cot theta, cot means what?
1 over 10.
1 over 10. This means 1 over this. Or reverse of this. Okay?
Yeah.
Or reverse of this. So 1 over 10, 1 over 1 by 0, what will be the value?
Indeterminate.
Indeterminate form. Right? 1 by this, 1
1 over 2.
and 1 over infinite. Right? What does it mean? That means you are dividing something over infinite. Infinite means huge, right? Something over infinite, huge, it tends to 0, right?
0?
Yeah. Something over infinite. Why? It tends to 0. Why? So for example, you have 1 here, and in the bottom 9 like this.
So it's also small letter 0?
Yeah.
Okay.
It's a huge number, infinite number, right? It tends to 0. If we think about now sec is
1 over 4.
1 over cos, means this, right? This line. 1 over 1, 1 over this.
Wait, এটা opposite side দিয়ে করা যায় না?
Yes, no,
No?
1 over cos.
তাহলে
Right?
তুমি এটা কেন opposite side দিয়ে করছো?
কোনটা?
এটা.
It opposite side, yeah, it can be, it is like this. But cos means 1 by sec.
Okay.
Let's do the mathematics, okay? No, sec is 1 by cos.
1 by.
It's 1 by 1 by this, 2 by root 3, 1 by this, root 2, 1 by this, 2, 1 by this,
Indeterminate.
indeterminate form. Then cosec,
1 over sine.
yes,
So indeterminate.
Okay.
2 root 2 over root 3 1.
Okay. This is your small table of trigonometric tables. It's the common angle in trigonometry is used. But right, there is a calculator. You can type in your calculator and you can find the value. Right. But earlier it was not like this. That these are the common angle actually in trigonometry we used to use. Okay.
Okay.
So you think about it and you can go through your text. Can I give a password? So these are the exercise actually is given, right? This is the angle, this is the value, what's the value will be y. So we need to find out those exercises, simple trigonometric.
Yeah.
You have to find out the ratio, right? Which is the appropriate ratio for here. To find out this one and what is qualities, right? So you need to find out, you need to do this. And as I told that this value of angle is 40, it is not in this year. You can type in your calculator, you can find it. Okay?
Okay.
So those are the calculations here.
কোথায় পর্যন্ত করব?
There's lot of things actually you can do. Come on, it's here. If you start from the beginning, right angle triangle, and go solve this.
Yeah.
Is the example, the exercise 2 is called, what is exercise 1? Let's see that actually.
But tomorrow morning, better I'm like additional maths boy use kori.
Yeah.
It's on 8 my ICC boy.
Yeah, I can look for that.
Yeah.
Exercise 1 is very simple. Exercise 2. Exercise 3. So and exercise 4. Yeah, bearing you need to get a lesson from Medha, or maybe you know about yourself. And some other exercises there you can see. It's called exercise 5. Scale drawing, something called exercise 6. Exercise 7 you can try. Sine cos theta, this is the angle, and this one. Okay, if you don't have any more questions, then we will meet next time.
Okay.
Okay.